Hello once again. Good evening, everyone. Spotting our travel, no words ever spoken. In my hour of need, crying alone. So, where are we? Joining data in SQL. Hello, everyone. This is Lola Rosa, and I guess I have to discuss again what I've discussed yesterday because yesterday I wasn't aware that my mic is not is not working on the OBS. So I streamed yesterday, but it has no sound. That was my fault. I haven't checked it out. So once again, I have to discuss training data in SQL. But first of all, why do we have to study data analytics? I guess it is very important right now because all the social media or all platforms and all except aside from the social media platforms, every business or aspect every aspect in our everyday lives today, we have to use the data to visualize, to plan, to forecast. So I guess this is the most in demand nowadays. The most in demand, what do you call this? Profession nowadays. Because aside from that, data analysis sharpens our problem-solving skills. So it will hone us be more to be more detailed oriented and to be more logical So, before anything else, as you can see, I insert again the sing along. Before I eliminated the sing portion because I think if ever I will have viewers in the future, maybe I'll what do you call this? I'm at a loss of words. I'm anticipating for the future reference of these videos that I don't want to have any copyright claims, but again, for my self gratification and self satisfaction, I really like to sing. So, before before I discuss the lesson, let me sing. Let me sing. This is a very nice song. In a little while from now, if I'm not feeling any less sour, I promise myself to treat myself and visit a nearby tower and climbing to the top to throw myself off in an effort to make it clear to whoever what it's like when you're shattered, left standing in the large at a church where people saying, my God, that's tough. Stood him up, no point in us remaining. He might as well go home as I did on my own, alone again, naturally. Think that only yesterday I was cheerful, bright and gay, looking forward to, well, who wouldn't do the role I was about to play. And as it to knock me down, reality came around, and without so much as a mere touch, cut me into little pieces, leaving me to doubt. Talk about God in His mercy, or if He really does exist. Why did He desert me in my hour of need? I truly am indeed alone again, naturally. It seems to me that there are more hearts broken in the world that can't be mended, left unattended. Oh, what do we do? What do we do? Looking back over the years, whatever else appears, I remember I cried when my father died, never wishing to hide the tears. And at 65 years old, my mother, God rest her soul, couldn't understand why the only man she'd ever loved had been taken, leaving her to start with a heart so badly broken. Despite encouragement from me, no words left forever spoken. When she passed away, I cried and cried naturally. That was a song from Ali McBeal. Here's another good song from Backstreet Boys. Remember when we never needed each other, the best of friends, like sister and brother. We understand we'd never be alone. Those days are gone. Now I want you so much. The night is gone, and I need your touch. Don't know what to say. Never meant to feel this way. Don't wanna be alone tonight. What can I do to make you mine? Falling so hard, so fast this time. What did I say? What did you do? How did I fall in love with you? I hear your voice and I start to tremble. Brings back the child that I resemble. I cannot pretend that we can still be friends. Don't wanna be alone tonight. What can I do to make you mine? Falling so hard, so fast this time. What did I say? What did you do? How did I fall in love with you? We'll want to say this life that it has to be tonight. Just need you to know I don't wanna live this life. I don't wanna say goodbye. With you I wanna spend the rest of my life. What can I do to make you mine? Falling so hard, so fast this time. What did I say? What did you do? How did I fall in love with you? What can I do to make you mine? Falling so hard, so fast this time. Everything's strange, we never knew. How did I fall in love with you? Just sing and sing until until I'm ready to discuss the lesson.
Thinking
I need a lover to keep me sane. Put me from hell, bring me back again. Play me the classics, something romantic. Give me my all when I don't even have it. I always dreamed of a solid base, someone who feels like a holiday. But now I'm pieces, barely believing, starting to think that I've lost all feeling. Came out of the blue on a rainy night, no lie. I tell you how I almost died, but you're bringing me back to life. I just wanna live in this moment forever, 'cause I'm afraid that living couldn't get any better. Started giving up on the word forever, until you gave up heaven so we could be together. You're my angel, angel baby, angel. You're my angel baby, baby, you're my angel, angel baby. Fall in love with the little things, counting the tattoos on your skin. Tell me your secret, and baby I'll keep it. And maybe we can play house for the weekend. You came out of the blue on a rainy night, no lie. I'll tell you how I almost died, while you're bringing me back to life. I just wanna live in this moment forever, 'cause I'm afraid that living couldn't get any better. Started giving up on the word forever, until you gave up heaven so we could be together. You're my angel, angel baby, angel. You're my angel baby, baby, you're my angel, angel baby. All the sick and twisted nights that I've been waiting for you, they were worth it all along, yeah. I just wanna live in this moment forever, 'cause I'm afraid that living couldn't get any better. Started giving up on the word forever, until we gave up heaven so we could be together. You're my angel, angel baby, angel. You're my angel baby, baby, you're my angel, angel baby, angel, angel baby, angel. You're my angel baby, baby, you're my angel, angel baby, angel. I'm learning new songs because before I only knew old songs. So now, please, I have some songs. Already sang 3 songs, another two. Another two before I start my lesson. When the rain is blowing in your face and the whole world is on your case, I could offer you a warm embrace to years. I could hold you for a million years to make you feel my love. I know you haven't made your mind up yet, but I will never do you wrong. I've known it from the moment that we met. No doubt in my mind where you belong. I'd go hungry, I'd go black and blue, and I'd go crawling down the avenue. No, there is nothing that I wouldn't do to make you feel my love. The storms are raging on the rolling sea, and on the highway of regret, the winds of change are blowing wild and free. You ain't seen nothing like me yet. I could make you happy, make your dreams come true. Nothing that I wouldn't do. Go to the ends of the earth for you to make you feel my love, to make you feel my love. Just one more song. Here you are the reason. There goes my heart beating, 'cause you are the reason I'm losing my sleep. Please come back now. And there goes my mind racing, and you are the reason that I'm still breathing. I'm hopeless now. I'd climb every mountain and swim every ocean, and just to be with you and fix what I've broken. 'Cause I need you to see that you are the reason. And there goes my hands shaking, and you are the reason. My heart keeps bleeding. I need you now. If I could turn back the clock, I'd make sure the light defeated the dark. I'd spend every hour of every day keeping you safe. I'd climb every mountain and swim every ocean, and just to be with you and fix what I've broken. Oh, 'cause I need you to see reason. Oh, you are the reason. Climb every mountain and swim every ocean, just to be with you and fix what I've broken. 'Cause I need you to see that you are the reason. Last song by Lady Gaga. Last song, then I'll start the lesson. It's very quick. That Arizona sky burning in your eyes. You look at me and babe, I wanna catch on fire. It's buried in my soul like California gold. You found the light in me that I couldn't find. So when I'm all choked up and I can't find the words, every time we say goodbye, baby, it hurts. When the sun goes down and the band won't play, I'll always remember us this way. Lovers in the night, poets trying to write. We don't know how to rhyme, but then we try. But all I really know, you're everywhere where I wanna go. The part of me that you will never die. So when I'm all choked up and I can't find the words, every time we say goodbye, baby, it hurts. When the sun goes down and the band won't play, I'll always remember us this way. Oh yeah, I don't wanna be just a memory, baby. When I'm all choked up and I can't find the words to say, every time we say goodbye, baby, it hurts. When the sun goes down and the band won't play, I'll always remember us this way. Yeah, when you look at me and the whole world fades, let me start the lesson. Enough with the singing. So, where are we now? Where are we now? Where do we go from here? Okay, what I was discussing is the joining data in SQL. Wait a minute. I think the washing machine. Let me. Arizona sky. You look at me and babe, I wanna catch on fire. So, what I was discussing is. Hi, hello for following. Eva, Eva's Creatives Carl. Thank you so much. So let me discuss.
Hello, my name is Maham Faisal Khan, and I'll be your instructor on a journey through the world of SQL joins. Joining data is an essential skill which enables us to draw information from separate tables together into a single, meaningful set of results. Although this course focuses on PostgreSQL, the material here applies to multiple forms of SQL. We'll begin with inner join, which along with left join makes up one of the two most common joins. Two tables, named left table and right table, are shown. Matching values of ID in both tables are shown in the same color. In both tables, the ID field is the key. A key is a single column or group of columns that uniquely identifies records in a table. Both tables also have fields called left val and right val, which will help visualize records returned after a join. With SQL joins, you can join on a key field or any other field. The inner join shown looks for records in both tables with the same values in the key field, ID. Arrows indicate records where the ID matches. In this diagram, we focus on records that match on ID and fade out any records that are not of interest to our inner join. The result is records with IDs 1 and 4. Throughout this course, we'll work with a database of world leaders. Our database schema is displayed here. It contains the president's, prime minister's, and monarch's tables, as well as the states table containing independence years, and the prime minister terms table providing years the prime minister's assumed office. Let's start querying our database by selecting all fields from the president's table. Recall the use of the asterisk in SQL to select all fields quickly. Here's a snippet of the prime minister's table from the same database. Suppose that we're interested in countries that have both a president and prime minister. In these small tables, we might notice that Egypt, Portugal, Pakistan, and India appear in both tables. For larger tables, though, it's not as feasible to identify these records by visual inspection. Here's where SQL joins can be helpful. The syntax for performing an inner join on our tables is shown step by step. It is common to begin constructing the query with the join first and selecting fields later. After from, we list the left table followed by the inner join keyword and the right table. We then specify the field to match the tables on using the on keyword. Here, we use the country field. Lastly, we add select at the start of the query and choose the fields we want returned. When selecting columns that exist in both tables, such as country and continent, the table.column-name format must be used to avoid a SQL error. The result of our query is displayed. 4 countries in our database have both presidents and prime ministers. In our inner join, we've had to type out president and prime minister several times. Luckily, we can alias table names using the same as keyword used to alias column names. Here, we use aliases P1 and P2 in both our select and on clauses to shorten our query. Before we end this lesson, let's add one more SQL shortcut to make our query even more concise. When joining on 2 identical column names, we can employ the using command, followed by the shared column name in parentheses. Here, since the join field is named country in both tables, we can use using. Now let's practice some joining.
Okay, so after the lecture, we have to answer the exercises. Okay, so let's see what it is in store for us here. So it says here, select all columns from cities. So since I have answered this yesterday, this is the answer. Select asterisk. Asterisk here denotes all the columns from a table. So we have to run the code and submit the answer. Then, okay, I forgot to read here. This is the instructions. So the next instruction is perform an inner join with the cities table on the left and the countries table on the right. Then it says here that do not use alias tables here or in the next step, because this is a step-by-step instruction. So after the select asterisk from cities, we have to use an inner join with the table countries. So we have to connect the table cities to the table countries. Then it says here that identify the relevant column names to join on by inspecting cities and countries tab in the console. The cities, we can inspect the content, the columns on the tables by clicking on the tabs here. So the cities have column name, country code, city proper, metro area, urban area, and etc. Okay. Then for the countries table, loading, we have here the code, name, continent, region, surface, area, independent share, and local name. So we have to inspect what is common between the two tables for them to have a relation, to check on the relation. So the common between them is here. It is on the countries table. It is the column name is code, whereas in the cities table it is country code. So we see that it is specified. The relation is cities that country code equals to countries that code. We have to specify the table that column and the relation. The relation is specified by the equal sign and then another table that column name. So we have to run the code, then submit the answer. Oh, Discord. Wait. I forgot. I forgot my Discord ID. I'll just I'll take a look at it again because I'm not using the Discord. But I have a Discord account, but I'm not using it. So graphics, branding, emotes, logos, overlay screens, and more. Next, okay. Next instruction is complete the select statement to keep only the name of the city, the name of the country, and the region the country is located in order specified. So we have to select the name of the city, which the table is cities. So cities dot name. Okay, then countries dot name. But since the two tables have the same column name, we have to use an alias to indicate to identify which of the names we are using. So it says here that alias the name of the city as city and the name of the country as country. So this is the code. Select cities that name as city and countries that name as country. Then the region of the country, countries that region. Since this is the column region has no identical column name from the other table, it is okay that we don't have use alias in this column. We only use alias for same column names from different tables to to so that we won't be confused, to eliminate the confusion. Okay, so from cities, cities is the left table and inner join with the table countries. Okay, on cities that country code equals to countries that code, then we have to run the code and submit the answer. It is I already have typed this yesterday. It's just that yesterday, while I was recording this video or answering these exercises, I haven't checked that my microphone is not working on OBS. I forgot to check. So when I found out I'm already finished with the stream, so that's why it has pre-written codes here. So up to up inspecting relationships. Okay, so joining with alias tables. Joining with alias tables, it says that from the video we have watched earlier, it says here that instead of writing full table names in queries, you can use tables aliasing as a shortcut. The alias can be used in other parts of your query, such as select statements. Okay. Then we have also learned that we can select fields. A field can be ambiguous. For example, imagine two tables, apples and oranges, both containing column code color. Then we have used the syntax apples color or oranges that color in your select statement to point SQL to the correct table. Without this, you have the following error. Okay. So in this exercise, we'll have to practice joining alias tables. It's already 8:37. 8:37. Wow. What do I need without you? I want to know. Come again, naturally. What do we do? What do we do? Okay, where are we now? Where are we now? Just keep it inside. So it says here that in this exercise, we'll practice joining with alias tables. We'll use data from both the countries and economies table. So this is the countries table, and this is the economies table. We have to inspect which of the two tables is the key, is the common. Okay, the common is the code from the countries and code from the economies. Okay. So for the instructions, start with inner join in line 5. Join the tables countries as C, and economies, write alias economies as E. So this is the line 5, inner join economies as E. From line 3, this is countries as C. Then use code as the joining field in line 7. And it is specified here that we don't have to use, we should not use the using command. It's specified that we do not choose the using command because it will be discussed in a latter part. Okay, so joining joining the country's code and the economy's code, we have here on C that code equals to E that code because we have aliased the countries as C and the economies as E. So that's why here we, instead of using the whole table name, which is countries and economies, we can use the alias. Then lastly, select the following columns in order in line 2. Line 2. So we have to select the columns code from countries. See here specifies the countries. So see that code as country code, then name, year, and inflation rate. Name, year, and inflation rate. C that name, E that year, and E that inflation rate. Okay. So have to run the code and why is there an error? Yesterday there's not an error. Okay. You should not every time we code with SQL, we should not forget the semicolon at the end of the statement. Okay, nicely done. What do we do? What do we do? Now we'll be using the using phrase. So from the previous exercises, we have performed joins using the on keyword. Then recall that when both the field names being joined are on the same, we can take advantage of the using clause because both the tables use the column name code for joining, so we can use the using code command here. So we'll be using the using phrase to simplify our query. Then using the country code field to complete the inner join with using, do not change any alias names. Okay. So once again, watching the video.
Welcome back. Now that we have written our very first SQL joins, it's time to think more conceptually about the kinds of relationships tables can have to each other. The first type of relationship we'll talk about is a one-to-many relationship. This is the most common type of relationship, one where a single entity can be associated with several entities. Think about a music library. One artist can produce many songs over their career. This is a one-to-many relationship. The same applies for authors and their books, directors and movie titles, and so on. Jane Austen wrote many books, and each of her books had just one author. In the table schema shown, Each of her works are stored in the books table and can be merged with the authors table using author ID from both tables. A second type of relationship is a one-to-one relationship. One-to-one relationships imply unique pairings between entities and are therefore less common. A commonly held premise of forensic science is that no two fingerprints are identical, and therefore that a particular fingerprint can only be generated by one person. This is an example of a one-to-one relationship. One fingerprint for one finger. Imagine fingerprint scanning at airport border control. Border control might have two tables in a database, a table of people and a table of their prints. Each person's fingerprint could be merged with the individual's table using their passport number. We won't cover this in detail here, but using a binary format is one way to store images, such as fingerprints, in a database. Note here that although an individual will have 4 fingerprints stored in the fingerprints table, this is not a one-to-many relationship. It's a one-to-one relationship because a single individual, represented as one record on the individuals table, will have one set of fingerprints, represented as one record on the fingerprints table. The 4 different fingerprints are 4 different fields in each record. The last type of relationship we'll discuss is a many-to-many relationship. An example of this is languages and countries. Here we show the official languages of Germany, Belgium, and the Netherlands, where we see that many languages can be spoken in many countries. For example, Belgium has 3 official languages: French, German, and Dutch. Conversely, languages can be official in many countries. Dutch is an official language of both the Netherlands and Belgium, but not Germany. Now that we've discussed the various relationships that can exist between tables, let's put this into practice.
What best describes the relationship code in the countries and country code between the code in the countries table and the country code in the cities table? The countries many-to-many relationship. Between the code in the countries table and the country code in the cities table. Okay. So it says here that from the example in the video, Belgium has 3 official languages, the French, German, and Dutch. And conversely, languages can be official in any countries. Dutch is an official language of both the Netherlands and Belgium, but not Germany because of the many types of relationships. There are many ways to join data. So we're already on inspecting the relationship. Inspecting the relationship. This is where I stopped yesterday. Okay. So we've just identified that the countries table has a many-to-many relationship with the languages table. That is, many languages can be spoken in a country and the language can be spoken in many countries. So, with this exercise, the first question is, what is the best way to query all the different languages spoken in a country? And second, how is it different from the way to query all the countries that speak each language? So recall that when writing joins, many users prefer to write SQL code out of order by writing the join first, along with it is writing the select statement at the end. We have to start with the join statement in line 6. Start with the join statement in line 6. Perform an inner join with countries table as C. On the left, with the languages table as L on the right. So inner join languages L from countries C. Make use of the using keyword to join code in line 8. Okay, using code. Then lastly in line 2, select country name, alias as country, and language name, alias as language. So have to run the code and submit the answer. Then next, rearrange the select statement so that the language column appears on left and the country column on the right. Sort the results by language, order by language, okay? Select the language column. So, since languages is alias as L and countries is alias as C, so it says language column L that name as language and C that name as country. Sort the results by language. So here in line here in line 7, order by language is the sort. Then says here that we have to generate code below, but since copying and pasting from here, copying from the instruction and pasting the interface is not possible, so I have to type it again here. Instead of instead of clicking on the run button, I click on the reset button, so I have to type it again. Let me see again if I can copy it. Can click on the copy button, but I cannot click on the paste here, so it's not possible. Okay. Promise myself. I just have to type it all again. So Alsatian is the language. Alsatian is Alsatian. What is that Alsatian? What is Alsatian? So Alsatian here is only on France. So this is nothing. There are at least three languages spoken in Armenia. Armenia. So where let's just see that Armenia. What is the question again? Ah, incorrect answer from the following options. Okay. So what is being asked is to check what is incorrect of the three options. So here Armenia has at least three languages spoken. So it is correct. And Alsatian is spoken in more than one country. Alsatian. The result here is only one. So the answer is this. Alsatian is spoken in more than one country. Is the incorrect. Is the incorrect of the following. Because Alsatian is only spoken in France. Okay.
We've seen a few inner joins and thought about the relationships tables can have to each other. Now it's time to level up our joins by building on these ideas. A powerful feature of SQL is that multiple joins can be combined and run in a single query. Let's have a look at some syntax for multiple joins. We begin with the same inner join as before and then chain another inner join to the result of our first inner join. Notice that we use leftTable.id in the last line of this example. If we want to perform the second join using the ID field of right table rather than left table, we can replace leftTable.id with rightTable.id in the final line. Thinking back to our example of world leaders, let's say that we are interested in identifying countries of the world that have both a president and a prime minister and want to know the year each prime minister came into office. Let's have a look at the prime minister terms table from our database of world leaders. It contains a prime minister column with prime minister names as well as a PM start column containing the start year of a prime minister's term. Let's apply the new syntax we've learned to our world leaders example. We can begin as before with an inner join of the president's and prime minister's tables using our aliasing skills to shorten the length of the query. Recall from our first lesson that the result set of this join was a combined table showing countries with both a prime minister and a president. If we now join the result of our first inner join with our prime minister terms table on the prime minister field, the final result will be only those countries with both prime ministers and presidents, along with the years their prime ministers assumed office. Notice that the prime minister terms table has 10 records, whereas our final result only has 4 records. This is because only 4 records from the prime minister terms table match the result of our first inner join. Here's a look at the final SQL query for chaining a second inner join to our first inner join. Notice that the syntax for the second join is exactly the same as for the first join, but we use prime minister as the field to join on instead. We can continue the chain and join as many tables together as we need. Great work! Now, let's step back from our world leaders example. One more thing to know about joins is that it isn't always the case that each value in the field being joined on corresponds to exactly one record in the joining field of the right table. In the example shown, if we join on one field as we've done before, the query will return multiple records from right table that match with left table on the ID field. We can limit the records returned by supplying an additional field to join on by adding the AND keyword to our ON clause. In this example, we join on date, a frequently used second column when joining on multiple fields. The result set now contains records that match on both ID and date. Now that we know how to chain multiple joins as well as how to join on multiple fields, let's get some practice.
So, for the exercises, joining multiple tables. We've seen that the ability to combine multiple joins using a single query is a powerful feature of SQL. Then, suppose you are interested in the relationship between fertility and unemployment rates. So, the tables here are populations, chest, fertility rate, and countries, economies. I think the unemployment rate, fertility against unemployment rate. Okay, unemployment rate exists on the economies table. Okay, so it says here that suppose you are interested in the relationship between the fertility and the unemployment rate. Then our task in this exercise is to join tables to return the country name, year, fertility rate, and employment rate in a single result from the countries, populations, and economies table. Country name, country name, country name, country name. Left with populations speed. Why is it populations? Populations speed. So the relevant tables is select name, year, fertility rate. What's name, countries is is the year-end fertility rate is in population. Year-end fertility rate. Population. Countries, populations, and economy stable. Name year fertility rate. Wrong. Does that exist on the right table? Using perform left the populations as B, right, on hold. With CNP, CNP, what's the connection between countries and populations? Countries and populations. Go. Populations is country. Go. Country. select name, your infertility rate. Okay. Then chain another inner join your query with economies table as E using code. Chain another inner join with economies table as E. Inner join economies as E. Then using code, using code. For the P, it is the country code, and economies has economies. What's the code? Code for the economies, and the population is country code again. Select name and using table. It is a select year and employment rate from economies. Check the highlighted code. Name your infertility rate. Okay. Because I see what is P, 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 P. So P. Define name in there. Name. Why? Why do I? Why do I? How can I get through my life without you? Name in there. Check the highlighted column. Select name, year, and fertility rate. Ano man na? Name. My name is the countries. Countries name. See that name. Population has no name in it, so only the countries and the economies. No, only the countries. So since the country code column is called code in the countries table, but country code range name, you need to use on rather than using tama naman. From on C code equals P country code. Since the country code column is called code in the countries, it's C code equals P country code. P country code. Come on. P country code equals E that code. also use using. To find year in learn, select name, year, and fertility. Okay. So we can use the fertility rate because it has an employment rate. Perform inner join on countries C, countries C, and left with populations B, right on who. Hmm. What's the problem? Could not find the first entry in the fields. Name and using table. It is select here and unemployment rate from economies. Name. Select name and using table. It is select here and unemployment rate from economies. Name. So once again, we're on to the last. We're just on the topic of introducing inner joins. Outer joins, inner joins. Okay, so uh, when checking multi-table joins. Now let's have a look at the results. For Albania from the previous query, you can see that 215, year 215 fertility rate has been paired with 2010 unemployment rate and vice versa. So instead of 4 records, the query should return two, one for each year. Okay. Fix the query by explicitly stating that both country code and year should match. So we have to modify query so that we are joining economies on year as well as code. Modify the query so that we are joining the economies on year as well as code.
Congratulations on completing Chapter 1 on inner joins and welcome to Chapter 2 on outer joins, cross joins, and self joins. Recall the inner join diagram from Chapter 1. The only records in the result were those where the ID field had matching values in both tables. We'll now compare inner join with three types of outer joins, beginning with left join. Outer joins can obtain records from other tables even if matches are not found for the field being joined on. A left join will return all records in the left table and those records in the right table that match on the joining field provided. In the diagram shown, the values of 2 and 3 do not appear in the ID field of right table, but will still be retained in the join. Records that are not of interest to a left join on the ID field have been faded out. We now look at the result of the left join on ID. Inner join returns only records corresponding to IDs 1 and 4, whereas left join keeps all records in left table as well as null values for right val where there is no match in right table. Note that IDs 5 and 6 in right table do not feature in left join in any way. Let's go back to our world leaders example. Say we want our query to include all countries with prime ministers, presidents if they happen to have them, and missing values if they don't. Left join will give us the results we need. The syntax of left join is very similar to inner join. Only the word inner is replaced with left. Note that left join can also be written as left outer join in SQL. The first three records in the result are the same as they were with an inner join, but from the fourth record, the result starts to look different. Since the United Kingdom does not have a president, a corresponding null value is returned in the president field. On to right join. Right join is the second type of outer join and is much less common than left join, so we won't spend as much time on it here. Instead of matching entries in the ID column of the left table to the ID column of the right table, a right join does the reverse. All records are retained from right table, even when ID doesn't find a corresponding match in left table. Null values are returned for the left value field in records that do not find a match. Generic syntax for a right join is shown. Note that the order of left table and right table is the same as in left join. The only change is that we call right join instead of left join. Right join can also be written as right outer join in SQL. Let's make this concrete with our world leaders example. We perform a right join of prime ministers on the left and presidents on the right. The only change is from the left join keyword to right join. The result contains null values where countries have presidents, but no prime ministers. Now that you're familiar with both left and right join, let's discuss why right join is less commonly used. A key reason for this is that a right join can always be rewritten as left join. Because we typically type from left to right, left join feels more intuitive to most users when constructing queries. Nice work on navigating some of the most popular types of joins. Let's practice. Congratulations on completing Chapter 1 on inner joins and welcome to Chapter 2 on outer joins, cross joins, and self joins. Recall the inner join diagram from Chapter 1. The only records in the result were those where the ID field had matching values in both tables. We'll now compare inner join with three types of outer joins, beginning with left join. Outer joins can obtain records from other tables even if matches are not found for the field being joined on. A left join will return all records in the left table and those records in the right table that match on the joining field provided. In the diagram shown, a left join
I'm repeating the video because I have some confusion about the left and right joint. Okay, that's why I keep on repeating it so that I could understand.
with three types of outer joins, beginning with left join. Outer joins can obtain records from other tables even if matches are not found for the field being.
Wait, wait. Left join will return all records in the left table, and those records in the right table that are matching that that match on the joining field provided. Okay. Okay. So all records in the left table and those records in the right table that match on the joining field provided. Okay.
Joined on. A left join will return all records in the left table and those records in the right table that match on the joining field provided. In the diagram shown, the values of 2 and 3 do not appear in the ID field of right table but will still be retained in the join. Records that are not of interest to a left join on the ID field have been faded out. We now look at the result of the left join on ID. Inner join returns only records corresponding.
Okay. Left, right,
Corresponding to IDs 1 and 4, whereas left join keeps all records in left table as well as null values for right val where there is no match in right table. Note that IDs 5 and 6 in right table do not feature in left join in any way. Let's go back to our world leaders example. Say we want our query to include
country, prime minister, president, from prime ministers, SP1, and joint presidency speak to same country. Same country, okay.
all countries with prime ministers, presidents if they happen to have them, and missing values if they don't. Left join will give us the results we need. The syntax of left join is very similar to inner join. Only the word inner is replaced with left. Note that left join can also be written as left outer join in SQL. The first three records in the result are the same as they were with an inner join, but from the fourth record, the result starts to look different. Since the United Kingdom does not have a president, a corresponding null value is returned in the president field. On to right join. Right join is the second type of outer join and is much less common than left join, so we won't spend as much time on it here. Instead of matching entries in the ID column of the left table to the ID column of the right table, a right join does the reverse. All records are retained from right table, even when ID doesn't find a corresponding match in left table. Null values are returned for the left value field in records that do not find a match. Generic syntax for a right join is shown. Note that the order of left table and right table is the same as in left join. The only change is that we call right join instead of left join. Right join can also be written as right outer join in SQL. Let's make this concrete with our world leaders example. We perform a right join of prime ministers on the left and presidents on the right. The only change is from the left join keyword to right join. The result contains null values where countries have presidents, but no prime ministers. Now that you're familiar with both left and right join, let's discuss why right join is less commonly used. A key reason for this is that a right join can always be rewritten as a left join. Because we typically type from left to right, left join feels more intuitive to most users when constructing queries. Nice work on navigating some of the most popular types of joins. Let's practice.
To the practice. And why does studying always makes me sleepy? Whereas watching K-dramas and watching music streams, I can watch continuously, but with studying, it always makes me want to sleepy. So, after familiarizing ourselves with inner joins, we'll have to come to grip with different kinds of outer joins. Then we will learn about cross joins, and finally, we will learn about situations in which you might join a table with itself. Okay. And it says here that to become faster at writing queries, it's helpful to memorize their structure. In this exercise, we will reconstruct the order of the steps by left join from memory. From memory, okay? So drag the code blocks provided to reorder them into syntactically correct SQL query. Okay. So the select here is the first. So select name as country, local name, from countries, left join language, order, using code, and is this obvious? The order by is on the last because the semicolon is here. It's the, what do you call it? Stopper. Stopper of a, I know there is another term for it, but it, this is what is used at the end of every statement. So yes, Yes, well done. It will be useful to know the core building blocks of a join like the back of your hand. So select, from, join, and on, and or using condition. So it has a sequence. It has an order on how do we use the phrases in a statement. Okay. Aren't they fucking? How do I? So this is a lecture. So again, in this exercise, we'll explore the differences between inner join and the left join. This will help us decide which type of join to use. So the instruction here is perform an inner join with cities at C1 on the left and countries at C2 on the right. So perform an inner join. Through my life without you. So inner join. C2. Then run code. Order by code. Control and countries. countries have code, code, and oh, you join. So it's wrong, 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 wrong. So cities have country code. So this is where the country code is. Country code and city have code. Code. Hi, hello, 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 Igor. How do you pronounce? Hello, hello there. Then I submitted the answer. Change the code to perform a left join instead of an inner join. So from join right people with alias. Join right people. Change the code to perform left join. Left join instead of an inner join. Countries. Countries. So before there were 100 out of 230 rows. Then after replacing the inner join with the left join, let's see how. Okay. So notice that the inner join resulted in 230 records, whereas the left join returned 236 records. So, okay, out of 236, okay. So remember that the left join is a type of outer join. Its result is not limited to only those who have records that have matches for both tables on the joining field. Okay. Okay. So when comparing two tables, the inner join only showing results with uh, records of the same, who has the same values, or those who have a relationship. So with inner join, with inner join, with inner join, the results records shown will only be those of what do you call it? Present within the two tables. But with left join, all the records on the left table, regardless, it has a corresponding link or corresponding records present on the right table. It shows all the records within the condition. So select name, region, GDP per capita. From countries as C, left join economies as E. Thank you so much, Gore. So, select name, region, GDP per capita from countries as C, left join economies as E. Match on coal fields. Okay. We're going back to the aggregate functions. Okay. We'll now revisit the use of the average function introduced in a previous course. Okay. Being able to build more than one SQL function into your query will enable you to write complex supercharged queries. So we will use the average in combination with the left join to determine the average gross domestic GDP, the average gross domestic product per capita by region in 2010. So for the instructions, complete the left join with the countries table on the left and the economies table on the right on the code field. So match on code field. Left join countries as C, left join economies as E. Then, so here's the relationship. Left join countries table on the left. Countries, what's the connection? Code. So see that code was, and economies is country code. Okay, it has the same. So code on the economies and code on the countries. So instead of using this, we have to use using code. Then Filter for the year 2010. Filter records from still running error because we have filter. So where year equals what is the year for the economies? Where okay. So since this has no, actually this is also correct, but uh, the checker here is only expecting year, uh, the year on the syntax because the year column has no other uh, has no similar column names on the other tables. So if there is, if the column is distinct on all of the tables, all of the tables from a query, it is okay to not specify the table name before the column. Okay, so but but running the code, it also gives us the same result. It's just that the checker here is very is um, very specific. Okay. So calculate per capita GDP per region, begin by grouping by region. Group by region. Since region has no identical columns, so we just have region. Then after you group by, choose region in your select statement. Select. Region. Where is the region? Countries. See that region. Okay. Followed by average. So it should be here. GDP per capita. Wait, why? GDP per capita. Using the average function as GDP. Okay. Okay. Run code and submit the answer. Then order the result by the average GDP per capita, highest to lowest. highest to lowest should be descending. Then return only first 10 records. Yes. I like it when the query is getting complicated. That's when I'm more hyped. But yes, okay. Now we've learned that right joins are not used as commonly as left. That the right joins are not used as commonly as the left joins. Then the key reason for that is that right joins can always be rewritten as left joins, and because joins are typically typed from left to right, joining from the left feels more intuitive when connecting queries. Okay. Then it can be tricky to wrap one's head around when the left and right joins return equivalent results. So we'll explore these in this exercise. And for the instructions, write a new query using the right join that produces an identical result to the left join provided. Okay, right. A new query using the left join that produces an identical result in the left join provided. I think use right join instead of the left join. So select countries, as country, languages, that name as same. From country, select join languages. So I guess it has to be from languages. From languages. Have just to reverse the what? I hope this is okay. Yes. Okay. So we just reversed the left and right. Just reverse the tables. Okay, so when converting a left join to right join, change both the type of join and the order of the tables to get equivalent results. Okay, you would get different results if you only change the table order. The order of fields you are joining on still does not matter.
In this video, we'll introduce full join. Full join is the last of the three types of outer join. We'll compare full join to the two other types of join we've learned, left join and right join, as well as to inner join. A full join combines a left join and a right join. As you can see in this diagram, no values are faded out as they were in earlier diagrams. This is because the full join will return all IDs irrespective of whether they have a match in the other table being joined. Let's have a look at the result after full join. We see that it has retained all IDs, returning missing values in the form of nulls for fields corresponding to records where ID did not find a match. All 6 IDs we've been working with are included in the result after the full join. We'll compare full join to the 2 other types of join we've learned, left join and right join, as well as to inner join. A full join combines a left join and a right join. As you can see in this diagram, no values are faded out as they were in earlier diagrams. This is because the full join will return all IDs irrespective of whether they have a match in the other table being joined. Let's have a look at the result after full join. We see that it has retained all IDs, returning missing values in the form of nulls for fields corresponding to records where ID did not find a match. All 6 IDs we've been working with are included in the result after the full join. Note that this time, nulls can appear in either left value or right value fields. Time for some SQL code. In order to produce a full join, the general format aligns closely with the SQL syntax we've been using for inner. Join, left join, and right join. We adapt our join to have the word full before join. Note that the keyword full outer join can also be used to return the same result. Let's make our sample syntax concrete with our example from the leaders database. Suppose we were interested in all the countries in our database and wanted to check whether they had a president, a prime minister, or both. We'll walk through the code line by line to do this using a full join. The select statement starts us off by including the country as well as the prime minister and president fields. Next, We specify prime ministers as our left table and alias this as P1. Note that order of tables matters here, and if we switch the order, the records would be ordered differently depending on how prime ministers and presidents are ordered in the tables. We then add the full join query and add presidents as the right table using alias P2. Lastly, the join is performed using country as the field to join on in both tables. We limit to the first 10 records. Here's a look at our result. Note that there are null values in both the Prime Minister and President fields. We chose a full join because we were interested in all countries, whether they had a Prime Minister, a President, or both. Time for some practice.
So for comparing joins, okay. This exercise will examine how results can differ when performing a full join. Uh-huh. Compared to a left join and inner join by joining the countries and currencies table. So the tables now are here, the countries and the currencies table. Hello, hello, hello. Hello to my two viewers. So then we'll be focusing on the North American region and the records where the name of the countries. So we'll begin with the full join with countries on the left and currencies on the right. Countries on the left. Select name as country, code, region, basically, and currencies. Join currencies. Full join. Currencies. Using code. So the countries has the column code and the currencies has also the common code. So it's okay using code. Then when region is North America or name is now. Where region, so it should be in countries. Where region North America or name. Where is the name? Name here. Name is now. So okay, we begin with the full join with countries on the left and currencies on the right. Then perform a full join. Filter the north. Okay. Submit answer. Should be correct. Yes. Then repeat the same query as before, turning your full join into a left join with the currencies table. So in the previous we've used the full join and now we'll be using the left join. Currencies. And using code or order. Then From the full join result, we have 4 rows. Now, then repeat the same tree again. Why does it show? It has the same result for all the 4 rows. Then repeat the same tree again. This time performing inner join with inner join. Okay. With countries with currencies. So instead of the full join and the left join, we'll be using the inner join. Inner join with currencies. Okay. Run the code and submit the answer. It shows only 3 rows. Okay. Then chaining pool joins. As you have seen in the previous chapter on inner joins, it is possible to chain joins in SQL, such as when looking to connect data from more than 2 tables. Suppose you're doing some research on what is Melanesia. Melanesia and Micronesia. So it is are the countries. Micronesia and Melanesia are they countries or regions? Region, because here condition specify. So since languages and currencies exist in separate tables, this will require 2 consecutive full joining involving the countries, languages, and currencies table. Okay, so we'll be joining 3 tables. Okay, it's possible as long as there are links. Then complete the full join with countries as C1 on the left and languages as L on the right, using code to perform this join. So full join. Countries on the left and languages. Full join. Languages as L. Full join with currencies as C2. Another full join. Full join. Currencies as C2. and we'll try new languages. Okay, code again. So the countries is code and languages is code. So okay, use the code. Then we'll join with currencies. Joining the code again. For currencies, Cito. Okay, code. So all have code, and code. Okay. So again, using code. Then run the code and submit the answer. Yes. Okay.
Now that we've worked with inner joins and 3 types of outer joins, we'll be checking out cross-join. Cross-joins are slightly different than joins we've seen previously. They create all possible combinations of 2 tables. Let's explore the diagram for a cross-join. In this diagram, we have 2 tables named Table 1 and Table 2 with 1 field each, ID 1 and ID 2 respectively. The result of the cross-join is all 9 combinations of the ID values of 1, 2, and 3 in Table 1 with the ID values of A, B, and C for Table 2. Let's have a look at the syntax for cross-join. Note that the syntax is very minimal and that we do not specify on or using with cross-join. Let's apply the SQL syntax for a cross-join to the following problem that uses our database of global leaders. Suppose that all prime ministers in Asia from our database are scheduled for individual meetings with all presidents in South America from our database, and we are journalists who wish to follow all the meetings that will happen. We can create a query that returns all these combinations using a cross-join. We use a where clause to focus only on prime ministers from Asia and presidents from South America. The results of the query give us all possible pairings of the 4 prime ministers from Asia in the prime ministers table and the 2 presidents from South America in the presidents table. We'll now dive into some exercises. Good luck!
As you are, never should know. Time so you but I guess I so. Select as country L as language. So we have to from countries. So inner joint countries C with languages is L on code. So we have to use using code. But it says here that what? be incredibly hard when asking questions that involve looking at all possible combinations or pairing between two sets of data. Imagine you have a researcher interested in spoken in two countries, Pakistan and India. What are languages presently spoken in the two countries? Then, given the shared history between the two countries, what languages could potentially have been spoken in either country over the course of their history? So we will explore how inner join and the cross join can help us see. So at first we have to use the inner join. Okay. Then for the instructions, complete the code to perform an inner join of countries as C with languages as L using the code field to obtain the languages currently spoken. Okay, so I think the code here is correct. So it shows 25 rows. Submit the answer. Then perform a cross join. Two languages is L. Okay. Question out. Wrong spelling is wrong. Wrong spelling is wrong. I've omitted the S from the languages. Mhm. So for the inner join, it has resulted returned 25 records, whereas when the cross join, it returned 50 records. So it took all combinations of languages. Okay. Okay. The more, the more the more the problem becomes complicated. That's how I am. When the problems are easier, I'm I'm I find it more difficult. But when the problem uh, gets more complicated, that's when I'm more I'm getting more hyped. Okay, and choosing your join. Now that we've fully equipped to use joins, try different problems to test our knowledge. Okay, so we will determine the names of 5 countries and their respective regions with the lowest life expectancy for the year 2010. Then use our knowledge about joins, filtering, sorting, and limiting to create this list. Okay. So complete the join of countries at C with populations as B. So join populations using an appropriate join. How do I know the appropriate join? Okay. Using countries This country code. Using C name as country, region, life expectancy. So we'll be using the name, the region, and life expectancy is from the population. Okay. I think it should be inner join. C dot code P dot attribute naman. So it joins countries that see with populations of speed and filter on the near content and sort the resource expectancy in ascending order. Then limit the countries. Limit the result to 5 countries. Yay. Okay. Then did you notice that more than one type of join can be used to return the 5 records? All 4 types of join have learned to return the same result. Okay. How far are we from the end of the chapter? Because I'm already sleepy again. Sleepy, sleepy, sleepy. Okay. So I'll just finish this chapter. Then the next 2 other chapters I'll be discussing again tomorrow. Okay.
Well done getting to the last lesson of this chapter. We'll now dive into a special kind of join, where a table is joined with itself. These types of joins are called self-joins. Joining a table to itself may seem like an unusual thing to do. Why would we want to do that? Self-joins are used to compare values from part of a table to other values from within the same table. Recall the Prime Minister's table from earlier. Suppose all Prime Ministers are convening in summits on their own continents. We want to create a new table showing all countries in the same continent as pairs. Self-joins don't have dedicated syntax as other joins we've seen do. We can't just write self-join in SQL code, for example. In addition, aliasing is required for a self-join. Let's look at a chunk of inner join code using the Prime Minister's table. The country column is selected twice, and so is the continent column. The Prime Minister's table is on both the left and the right of the join, making this both a self-join and an inner join. The vital step here is setting the joining fields which we use to match the table to itself. For each country, we will find multiple matched countries in the right table since we are joining on continent. Each of
I have to replay it again for me to fully understand the transcript.
We'll now dive into a special kind of join, where a table is joined with itself. These types of joins are called self-joins. Joining a table to itself may seem like an unusual thing to do. Why would we want to do that? Self-joins are used to compare values from part of a table to other values from within the same table. Recall the Prime Minister's table from earlier. Suppose all Prime Ministers are convening in summits on their own continents. We want to create a new table showing all countries in the same continent as pairs. Self-joins don't have dedicated syntax as other joins we've seen do. We can't just write self-join in SQL code, for example. In addition, aliasing is required for a self-join. Let's look at a chunk of inner join code using the Prime Minister's table. The country column is selected twice, and so is the continent column. The Prime Minister's table is on both the left and the right of the join, making this both a self-join and an inner join. The vital step here is setting the joining fields which we use to match the table to itself. For each country, we will find multiple matched countries in the right table since we are joining on continent. Each of these matched countries will be returned as pairs. Since this query will return several records, we use limit to return only the first 10 records. The results are a pairing of each country with every other country in the same continent. However, note that our join also paired countries with themselves, since they too are in the same continent as themselves. We don't want to include these since a leader from Portugal does not need to meet with themselves, for example. Let's fix this. Recall the use of the AND clause to ensure multiple conditions are met in the ON clause. In our second condition, we use the not equal to operator to exclude records where the p1.country and p2.country fields are identical. Here's a look at our final table, showing combinations of countries in our database that are in the same continent, but excluding records where the two country fields are the same. Nice work! You'll now work on a couple of exercises for practice, then complete a joining challenge.
So it says here that in this exercise, we'll work to answer this question by joining it. What is the question again? It's okay. Comparing a country to itself. Self-joins are very useful for comparing data from one part of a table with another part of the same table. Okay. Suppose we are interested in finding out how much the populations for each country changed from 2010 to 2015. We can visualize this change by performing a self-join. Okay? So in this exercise, we'll work to answer this question by joining the populations table with itself. Recall that with self-joins, tables must be aliased. Use this as an opportunity to practice your aliasing. Okay. Since we'll be joining the populations table to itself, we can all alias populations first as P1 and again as P2. Control. So all joins on deck. Then, the end of the chapter, we will test our knowledge. For each of the problems presented, think carefully about what types of table are involved and how each of the joins you have learned relates to null values. Drag and drop the situations presented into the appropriate type of join. So for the cards, you want to report, you want a report of whether your patients have reached out to you or you have reached out to them. You are fine with nulls for either conditions. So
Welcome back for Chapter 3. In this chapter,
I'll stop here. Continuation will be tomorrow for the chapter 3 and 4 for the completion of the course. But so far, I think had the complete grasp on what is the join, the inner join, the outer join, the cross joints, and the sub join. So that's all for today.